This is section 1.3, Introduction to Measuring Segments. This is part 2. In part 1, we talked about the segment addition postulate and how to measure lines and from one point to another. In this section, we're going to talk about some other topics here as well when it talks to lines. And the first one is another one. It's another concept that you're going to use a lot throughout the year. Okay, it says the midpoint of a segment is the point that divides the segment into two congruent segments. Okay, so essentially the midpoint is exactly in the middle. It's exactly what it says it is. Okay, a point, line, ray, or other segment that intersects a segment at its midpoint is said to bisect the segment. This is a key word here, bisect. Anytime you intersect a segment with another line, so what two lines are intersecting, and you can see that from this picture right here. You have line AC, and then you have line L. Line L is intersecting AC at point B, which happens to be right in the middle. That's what they call a bisect. Okay, so you're going to bisect something. That point, line, ray, or segment is called a segment bisector. So in this case, line L is the segment bisector of AC. Okay. So it says B is the midpoint of AC. So if B is the midpoint of AC, one thing that you want to jot down here, if B is exactly in the middle of this whole line, this means is that these two parts are congruent. So I could say that segment AB is congruent to segment BC. Okay? So that's what that means in terms of being a midpoint. What it means is that these two parts are equal to each other. Okay, that's different from the segment addition postulate. The segment addition postulate said part plus part equals whole. Now we're talking about saying that these two parts are equal. We're going to set them equal to each other to figure out our answer. Okay, so let's take a look at a couple of examples here. It says U is the midpoint of TV. What are TU, UV, and TV? So if U is the midpoint of TV, I know two things. I know that this and this are congruent to each other, or TU is congruent to UV. Segment TU and segment UV are congruent to each other. So how much is segment TU? According to the line, it says TU is 8x plus 11. And according to the line, UV is 12x minus 1. Now you'll notice I changed from a congruent to an equal sign. Anytime we throw in numbers, now those are values. Remember, if we have values and we know how long that is, we use an equal sign. If we're just talking about the line segments, we're going to use congruent. Okay? So now I need to solve this for x. I got to figure out how much x is first. Then I'm going to plug it in to find the other values. Okay? So maybe if you want to put some steps here, you want to solve for x first. Then once you find x, you're going to plug x back in to the expressions. Okay? And then finally, to figure out the last part, you're going to, for the whole, for TV, you're going to add TU and UV. Add segments TU and UV together. Okay? So that's kind of a process in how you're going to look at these problems. All right? So to solve for x, I'm going to go ahead, I'm going to subtract 8x from each side here. And I've got 11 now is going to equal 4x minus 1. I'm going to add 1 to each side, and I get 12 equals 4x. And I divide by 4, and x is going to equal 3. Okay, so I solved for x. I took care of the first step. Now I've got to plug them back in. So I've got TU, which is 8x plus 11. So I've got 8 times 3 plus 11. All I'm doing here is simple substitution. So this is 24 plus 11, which is 35. Okay? I'm going to check UV, but if you'll recognize if they're the midpoint, we said they're equal to each other, UV better be 35. If it's not, then I screwed up somewhere. So 12 times x minus 1, 12 times 3 minus 1. 12 times 3 is 36, minus 1 is 35. So it checks out. Okay? And if TU and UV are both 35, then TV is going to be 35 plus 35, which is 70. Now there, you're using the segment addition postulate. Okay? So this is an example of how to use the midpoint to solve an example here. Okay? All right, let's take a look over here at, what I'm going to have you do is I want you to have this problem right here completed for me for class. Okay, so that's part of your WSQ as well. Okay, let's take a look at this example here, and this one's a little bit different because now we have two intersecting lines, and these two lines bisect each other. Okay, I've added in some picture here, some more knowledge here from the picture. From the picture, as you look at the picture, you'll notice that these two marks here mean that these two segments are congruent, which means that D is the midpoint of AC. That's the first one. Okay, D is the midpoint of line segment AC. If you look at these two marks, that means those two lines are equal, those two segments are equal. So I could say that D is also the midpoint of BE. Okay, so let's take a look at number one. Number one says if AD is 20 and AC is 3x plus 4, find the value of x, then find AC and DC. Okay, so AD is this segment right here, that's 20. AC is the whole thing, which is 3x plus 4. Okay, well, if AD is 20, and I'll go ahead and mark this on here, if AD is 20, then that also means that, since again, AD and DC are equal, this is 20. So how long is AC? That is 40. So now I can say AC, it says, is 3x plus 4, and this needs to be equal to 40 units. Okay, if I had to actually find the value of x here. Okay. Now, as we're looking at this problem, okay, to solve for x, if I subtract 4, 3x is 36, and if I divide by 3, x is 12. So I found the value of x. Because again, remember, these two segments are equal because D is the midpoint. And then if I plug them in, okay, if I plug it into 3x plus 4, or excuse me, if I know that AD is 20, then I know that DC is 20 because they're the midpoint. They're the same. And then if I need to figure out AC is just going to be those two segments added together, which is 40. Okay. Okay, now let's take a look here at number 2. Number 2 says if ED is 5y plus 6 and DB is y plus 30, find the value of y first. Okay, so let's write these in up here. ED is 5y plus 6. So that guy right there is 5y plus 6. And DB is y plus 30. Okay, find the value of y. Well, I know that D is the midpoint. These two right here are equal. So I can set this up to say 5y plus 6 equals y plus 30. And if I subtract y from each side, I get 4y plus 6 equals 30. If I subtract 6, 4y is 24. And if I divide by 4, y is going to be 6. Okay, now if y is 6, I should be able to figure out ED, DB, and EB, all three of them. Okay, so 5 times y plus 6, or 5 times 6 plus 6. 5 times 6 is 30, plus 6 is 36. And that happens to be segment ED. Okay, that's segment ED, which is the same as DB. So those two are both 36. And then EB is going to be 36 plus 36, which is 72. Okay. All right, so this kind of goes through and shows you how the midpoint works. Now, there's two extra problems here. I want you to do 3 and 4 for me by the time you come to class tomorrow. Okay. So you should have 3 problems to complete, along with, don't forget your WSQ for part 2, of section 1.3.